Hi guys, this is Steven from Smart IQ. So today I'll be showing us how to solve equating polynomials. So it's called equating polynomials. So now before, this is a very popular question in SAT mathematics that most students normally dodge. So I'll be showing us how to solve it. But before we go into the exact question, I want to let us in into the introduction of polynomial. So for polynomial, we have different type of polynomial. We have the constant polynomial. We have constant. I believe you can see this. Constant polynomial. Right? So constant polynomial, let's just take a particular value. So it will be what? Let's say example 6. This is a constant. So it has no letters attached. So another one is the what? The linear polynomial. The linear polynomial. Linear polynomial, right? So an example of linear polynomial will have what? 6x plus 1, right? So the degree of x is 1. You have this, the degree of x is raised to the power of 1. Now, then the other one we have binomial, right? Binomial. So this is to the degree of 2. Let's say 6x squared, right? Plus x plus 1. This is a binomial. We can also say this one is x plus what? Okay, this is a linear polynomial. So we have 6x here plus 1. So this is correct like this. So we have another type also called the we call it the trinomial. You can call it the trinomial, where the power is raised to the power of 4. Trinomial, right? So that will be 6x raised to the power of 3 plus, let's say, 2x raised to the power of 2 plus x plus 1. So this is how we go till you get to the quadratic polynomial raised to the power of 4. So this binomial, you can call it quadratic. Also, this is also known as what? Quadratic. For the binomial, you can also call it what? A quadratic. So there's something I want you to know about polynomial. Now, for any polynomial equation, let's take what? 6x. Let's take 6x plus 1. So we call this the what? Coefficient. We call this the coefficient, while we call this the variable. And the power, right, is the degree. This is raised to the power of 1. So it is the degree, it is to the degree of 1. And this is the what? Constant. So I believe with this you'll be able to understand what are the different type of polynomials. So let's go right into the equation. So like I said, this is a type of SAT questions, common in SAT questions that most students normally dodge, and it is actually simple. So I call it what? Equating polynomial. So I'll give us an example of that. So we have ax plus 3, ax plus 3 in bracket. We have 5x squared. So in bracket, 5x squared minus bx plus 4, right, equal to 20, equal to 20x cubed. 20x cubed minus 9x squared minus 9x squared minus 2x plus 12. So the question says find a. So we are looking for a. In this kind of equation, you can see that we have the right hand side, we have the left hand side, and we have the what? The right hand side. Now, this polynomial, this is a polynomial in an algebraic form that you need to solve. Then after resolving it, you equate each of them to see how to get the what? The variable. Now we have find a. The question is find a b. Now what do? We pick out this side. This right hand side looks as if it has been solved. It looks as if it has been solved, right? There is nothing to do here, so we need to expand this so we can equate it based on their the degrees. Now I've told you what the degree of polynomial is, the coefficient, and and different type of polynomial. So let's solve the left hand side. So we say left hand solution. So we have ax, so when we multiply we have what? 5ax cubed minus abx squared plus 4ax plus 15x squared. I hope you are following me. Plus 15x squared minus 3 times this, it will be minus 3 minus 3bx minus 3bx plus 12, right? So we'll now try to collect like terms, right? So we have 5ax cubed, and we have square here, so we are bringing in minus abx squared plus 15x squared minus this 15x squared, right? We have xx plus 4ax minus 3bx plus 12. This looks better. Now we can continue to say 5ax cubed, right, plus ab, that is, we can say plus 15, right, minus ab x squared. Now we factorize to get x squared out. So we can say for here too, we have what? 4a minus 3b x plus 12, right? Now what do? We know that this is for x squared, this is the coefficient for what? X, and this is the constant, and this is the coefficient. 5a is the coefficient for x cubed. So we can now equate this particular expression to this one. Now equating it to be what? Equal to what? 20x cubed minus 9x squared, so minus 2x plus 12. So what do? We begin to equate them. That's why I call it what? Equating polynomials. We begin to equate them to themselves. So we'll have that for equation 1. We'll have that what? 5ax cubed equal to what? 20x cubed. You can see they are both common. So for 2, we have that 15 minus ab x squared is equal to, what do we have for x squared? Minus what? 9x squared, right? So we can just clean the above. So this is a trick that works for equating polynomials, this kind of algebra in SAT questions. So let's not clean what we've already solved. So now we have this equation 1, equation 2, and by equating their coefficient, we are equating them based on their what? The degree. Now we have that 4a minus b, so equation 3 can come here. Equation 3 is 4a, right, minus 3b x is equal to what? Minus 2x. So this constant is equal to this constant. So let's leave that. Now we can now begin to solve from equation 1. From what? From equation 1, we have 5ax cubed equal to 20x cubed. So we can say this go with this, this go with this. So our a is equal to what? 4. right? So from equation 2 we have what? From equation 2 we have from equation 2 we have 15 minus AB 15 minus AB x equal to minus 9x squared. I think it is x squared. So we know this will go with this. So we have minus AB is equal to minus 9 minus 15. So minus AB is equal to minus 9 plus 15 is 24. So it will be negative 24. Negative 24. So we know A, so negative will go with negative. We know A to be what? 4. So it will be what? 4. So let's say put A equal to 4. That's impute A equal to 4. Now we have 4B equal to 24. So we know that B will give us what? 6. So we know our A as 4 and our B as 6. So they told us to find A, we got in A. Then for AB will be what? 6 times what? 4, which will give us what? 24. So I believe you are able to understand this. So at first you look for the part you need to solve, then you solve that particular part, then you equate it with the what? With the other side of the equation. Then you use the degree to equate them, so you can get the missing alphabet. So we'll be taking another question so that we are able to understand this fully. Like I said, this is a common SAT question. You get up to 3 to 4 questions from equating polynomials. So now you know what polynomial is. It's just how to solve equating polynomial. It's not like you are just subtracting. So I'll be giving us another one. We have 2ax minus 15 is equal to 3x plus 5 and plus, just to show you, 5x minus 1. And this equating polynomial works. Now, so this place looks already solved, so we'll solve the right hand side. So right hand solution. So we are going to be solving this place, expanding this one. So we have what? 3x plus 15 plus 5x minus 5, right? So we'll have 8x minus 10. So therefore we'll say 2ax minus 15 is equal to 8x minus 10, right? So what do? We equate them. This will be equal to this, so we forget about this other part. So we know that 2ax is equal to 8x because they have same degree, right? Now we'll cancel the x, 2 here, a will give us what? 4. So guys, this is how to solve equating polynomials in SAT mathematics. Thank you.